Everyone thinks a shadow is just a shadow. They're wrong. It's a cosmic ruler. A shadow isn't just a dark spot on the ground. It's a silent, ever-changing portrait of our planet's rotation, a daily cosmic dance unfolding right before our eyes. And nowhere is this dance more dramatically choreographed than at dawn and dusk. You've seen it yourself, that impossibly long, stretched-out figure trailing behind you as the sun dips below the horizon. It can feel almost theatrical, turning an ordinary walk into a dramatic silhouette. But why does this happen? To understand this daily phenomenon, we need to consider the source of all light on Earth, our magnificent sun. For us, it appears as a consistent, radiant orb, but its position in the sky is anything but static. Think back to midday. The sun is high above, almost directly overhead in many parts of the world. At this point, the light rays are hitting the Earth at a steep, nearly vertical angle. This is crucial for how shadows form. When the sun's rays are coming down vertically, they hit your body or any object and cast a shadow that's quite compact, close to your feet. It's essentially a direct projection of your shape onto the ground beneath you. Now fast forward to the late afternoon or early morning. The sun isn't directly overhead anymore. It's much lower in the sky, closer to the horizon. This changes everything about how those light rays interact with us. As the sun descends, its light rays hit the Earth at a much shallower, more oblique angle. Imagine shining a flashlight directly down onto a table versus shining it almost horizontally across the table. The difference is stark. When the sun is low, those light rays have to travel a greater distance through the atmosphere. They're also hitting your body and then continuing their path across the ground for a longer stretch before finally being blocked. This shallow angle means that for every bit of height an object has, say, your head, the shadow it casts on the ground is stretched out significantly. It's like taking a short stick and laying it down almost flat on the ground. Its shadow will be much longer than if you held it straight up. It's not just the angle, but also the relative position of the light source. When the sun is high, it's above us. When it's low, it's ahead or behind us, depending on the time of day, effectively pushing that shadow outward. This principle isn't exclusive to human shadows. Look at a tall building at sunrise or sunset. Its shadow can stretch for blocks, creating dramatic lines across cityscapes. At noon, that same building's shadow might barely extend beyond its base. This dance of light and shadow has fascinated artists and scientists for centuries. Ancient civilizations used shadow length to tell time and mark seasons long before clocks became common. It was a natural, universal timepiece. The Egyptians, for example, built obelisks not just as monuments, but as giant sundials. The length and direction of their shadows provided a surprisingly accurate measure of the day's progression. The Greeks, too, recognized the power of shadows. Eratosthenes, a brilliant Greek mathematician and geographer around 240 BC, famously used shadow lengths to calculate the Earth's circumference with remarkable accuracy. He observed that on the summer solstice, a well in Syene, modern Aswan, had no shadow at noon, meaning the sun was directly overhead. But in Alexandria, a city to the north, a vertical pole still cast a small shadow. By measuring the angle of that shadow in Alexandria and knowing the distance between the two cities, Eratosthenes applied simple geometry. His calculation was incredibly close to modern measurements, a testament to the power of observation. So the next time you see that incredibly long shadow stretching out before you at sunset, remember it's not just an optical illusion. It's a fundamental principle of light and geometry, an echo of ancient science. It's the sun, lower in its daily arc, casting its light across the Earth at a shallow angle, causing objects to project dramatically elongated versions of themselves onto the ground. And at noon, when the sun is at its highest, the opposite is true. The light comes down steeply, creating those short, compact shadows that huddle close to the base of whatever is blocking the light. It's a beautiful, everyday reminder of our planet's constant motion, its tilt, and its relationship with our star. Each sunrise and sunset isn't just a pretty view, it's a physics lesson playing out in grand scale. And it reminds us that even the most common observations, like a lengthening shadow, hold layers of scientific wonder waiting to be explored. It's an invitation to look a little closer, to ask why. From the grand calculations of ancient astronomers to the simple joy of watching your own shadow stretch out like a giant, the gravity of a shadow is more profound than we often realize. Next, let's uncover why the sky is blue, but sunsets are red.